Hi, everyone. Today we are going to talk about finding or evaluating inverse trig functions and the relationship between inverse trig functions and right triangles. So the very first part of the notes that we're going to go over today is dealing with just a little bit of review of evaluating inverse trig functions, thinking back to the unit circle. So I'm going to do a couple of them, and then I'm going to have you pause the video and go ahead and do the rest. So looking at number one, we're finding inverse sine of √3/2. Now, one thing that you need to be wary of is the fact that inverse trig functions have a restricted range. And so when you're looking for the angle that's associated with that trig ratio, for sine, you basically should just be looking in quadrants 1 and 2. So I like to draw this little diagram, and that's from pi/2 to negative pi/2. And so that is for sine, inverse sine. These are the range of values you can choose for your output. Okay, for cosine, we go from 0 to pi, so quadrants 1 and 2. And then let's do 0 and pi. And then inverse tangent, just be careful because you don't, it's undefined at pi/2 and negative pi/2, so we don't want to include that, but you're also looking in quadrants 1 and 4, so that's for inverse tangent. Okay, so that might help you kind of figure out the rest of those. Okay, so inverse sine is asking you, what angle do I have a y coordinate that's √3/2? Well, that happens in quadrant 1, because it's positive, at pi/3. Right, that's up here, right? Okay, number 2 is asking you where in quadrants, now 1 or 2 is where we're looking at from 0 to pi, do I have an x coordinate of negative 1/2? Well, it's definitely going to have to be in quadrant 2. And so then thinking about what your triangle would look like, it would be like this, right? And so that's going to be at 2 pi/3. All right, so go ahead and pause this video here. Go ahead and do 3 through 6, then unpause and I'll go over them. All right, inverse tangent of 1. This is asking you where on your unit circle would y/x be 1? Well, that's going to be at pi/4, because that's where your x and y coordinate are equal. Because it's positive, it has to be in quadrant 1. Okay, number 4 is asking you where in quadrants either 1 or 4, since it's inverse sine, is your y coordinate negative √2/2. Well, that's going to be in quadrant 4, and that's going to be at negative pi/4. Be careful, it's not 5 pi/4, because our range is from negative pi/2 to pi/2. Okay, number 5 is asking you where on your unit circle is y/x negative √3. Well, that's going to have to be in quadrant 4, and then that's going to happen at negative pi/3. Number 6 is asking you where in quadrants 1 or 2, or from 0 to pi, is your x coordinate -1, and that happens at pi, number 6. Okay, so let's see how this relates to right triangles. So let's take a look at a right triangle here. We're going to do some labeling. So we have theta right here, and we're going to think of this as a reference triangle because we're not necessarily going to have only acute angles that we're working with in the future, but this is a reference triangle. Our reference angle is theta. We have our hypotenuse, we have our adjacent leg, and we have our opposite leg. Okay, so we're going to start with the trig function of inverse sine. Now for inverse trig functions, we plug in the ratio and we get out the angle. It's switched. Domain and range are switched for inverses. So we're going to plug in opposite over hypotenuse and we should get out theta. Now the domain, be careful, domain and range for sine and inverse sine are switched. So the range of just regular sine, think of your sine curve, it goes from -1 to 1, so that becomes your domain, -1 to 1. Whoops. Now your range, be careful, remember we restrict the range of inverse sine to be from -pi/2 to pi/2. Okay, inverse cosine, we plug in the ratio, which would be adjacent over hypotenuse. And that equals your angle theta. The domain would also be from -1 to 1. And then the range is going to be from 0 to pi. Remember, we look in quadrants 1 or 2 for the output angle. All right, last one, we have inverse tangent. And we plug in opposite over adjacent, our trig ratio. And we get out theta. The domain for inverse tangent is actually -infinity to +infinity. And then the range, remember it's quadrants 1 and 4 for inverse tangent, but we don't include the endpoints. So it's going to be from -pi/2 parentheses to pi/2. And that's because it's undefined at pi/2 and -pi/2. Okay, let's go ahead and do a little bit of review. This is actually more review from geometry than anything. So in numbers 1 through 4, you're being asked to solve for the missing angle theta. So let's take a look at number 1. Well, to solve for missing angles, we have to use inverse. Now we're given the adjacent and the hypotenuse. So it looks like we're going to want to use inverse cosine. So theta is equal to inverse cosine of adjacent, which is 6, over hypotenuse, which is 13. Then, if I punch that into a calculator, be careful of what mode you're in versus radians and degrees. I'm in degrees, so you get 62.514 approximately in degrees. If you're giving me degrees, make sure you include the degree of units. If you're giving me radians, make sure you write RAD so I know what you're in. Okay, go ahead and pause here and do 2 through 4, and then I'll go over them. Okay, number 2, we are solving for theta once again. We are given the opposite leg and the hypotenuse. So it looks like we're going to use inverse sine. So theta equals inverse sine of opposite, which is 4, over 7. If you punch that into a calculator, you get about 34.850. We're in around to 3 decimal places, degrees. Okay, number 3, it looks like we're going to use inverse tangent. We have opposite, which is 3, over adjacent, which is 11, and that will equal theta. Therefore, theta is approximately 15.255 degrees. All right, last one, number 4. You might actually notice something about this problem. And you could use trig to solve it, but 12 root 3 and 24, I'm going to take a wild guess and say that this is 12, which it is if you do Pythagorean theorem. And what rule is this? Well, this would be x, 2x, and x root 3. So what is theta? Well, it actually is going to be 30 degrees. This is a 30, 60, 90 triangle. Now, if you didn't figure that out, what you could have done is done the ratio. So you would have said, well, theta would equal, we're given the adjacent and the hypotenuse, so inverse cosine of 12 root 3 over 24. Well, if you simplified that, it's inverse cosine of root 3 over 2, which is 30 degrees. Okay, so you did not really need a calculator for that one. All right, so let's go ahead and move on. Now what we're going to do is kind of work backwards. We're given an answer, and we need to find theta between 0 and 180 degrees that satisfies the given problem. Okay, so let's start with number 1. Sine of theta equals 0.4. Now note that this is greater than 0, it's positive. And because we are looking for an answer in quadrants 1 or 2, right, from 0 degrees to 180 degrees, and sine is actually positive in both of those quadrants, there's actually going to be 2 solutions to this problem. There should be one in quadrant 1 and there should be one in quadrant 2. So the problem is you could find the first one by saying that theta is inverse sine of 0.4. That would give you the solution in quadrant 1. And so that is approximately, if you do a calculator, let's call this theta 1, right? Because that's our first answer. So theta 1 is about 23.578 degrees. Okay, but there's a problem here. This is not the only answer. We also need to figure out the answer that's in quadrant 2. Well, if you remember, these answers, this was theta 1, right? Approximately. And theta 2 is going to actually kind of be symmetrical over here. And so we need to figure out what theta 2 would be. Well, there's actually an easy way to do that. Because these are congruent angles, and you actually want to find out this angle for theta 2, okay, you can actually just take theta 1 and subtract away, or 180 degrees, and subtract away theta 1. So it would be 180 degrees minus the inverse sine of 0.4. These angles are supplementary. In other words, they add up to 180 degrees. Okay, so theta 2, if you punch that into a calculator, you'll get approximately 156.422 degrees. Okay, so let me box those answers. All right, let's try one more. Let's try number 2. So number 2, we have cosine of theta now equals 0.4, and we're looking for answers from 0 to 180 degrees. Well, luckily for us, there is only going to be one answer in quadrant 1 for this one, because cosine is actually negative in quadrant 2. So we only need to find one answer, and we can just do inverse cosine of 0.4, which if you punch that into a calculator, we get about 66.422 degrees. Okay, go ahead and try numbers 3 and 4. So pause here and then we'll go over them together. All right, let's take a look at number 3. We have sine of theta equals 1/4. So if I draw this out, remember we're looking in quadrant 1 and quadrant 2. Well, we have a slight problem here because sine is positive in both of these quadrants, meaning there is going to be more than one answer. To get the first answer, we can just use inverse trig. That gives us the answer in quadrant 1. sine inverse or arc sine of 1/4. If you punch that into a calculator, your first answer is 14.478 degrees. So remember, these angles are supplementary to each other. This was your theta 1. This is your theta 2, the one in quadrant 2. So we can find theta 2 by just taking 180 degrees and subtracting off inverse sine of 1/4. When you punch that into a calculator for theta 2, you get about 165.522 degrees. Okay. Last one, number 4. Cosine of theta equals 1/9. So for this one, we are only going to get one answer. It's going to be in quadrant 1, since we're looking from 0 degrees to 180 degrees. It's going to be in quadrant 1 because sine is not positive in quadrant 2. So we're just going to do theta equals inverse cosine of 1/9. And theta is approximately 83.621 degrees. Okay, and that is it for those 4 problems. Okay, in the next section, we're evaluating compositions of trig functions. So let's take a look at number 1. We're trying to find cosine of inverse sine of 3/5. Okay, here's my recommendation. Draw a picture. Now, because we're taking inverse sine of a positive, guess what? Your angle is in quadrant 1 because inverse sine lives in quadrants 1 or 2. And you can use that to draw a reference triangle. Okay, so sine is opposite over hypotenuse. So opposite is 3, hypotenuse is 5. You may recognize this is a 3, 4, 5 triangle, so you can very easily, without Pythagorean theorem, find that third side. Well, in quadrant 1, cosine is positive, so you don't have to worry about that. This is just cosine of this reference triangle, which would be adjacent, which is 4, over hypotenuse, which is 5. So you get an answer for this one of 4/5. Okay, let's do one more together. Let's take a look at number 3. So we have sine of inverse cosine of -8 over 11. So once again, I'm going to draw a little picture. Now, because we're taking inverse cosine of a negative, and inverse cosine lives in quadrants 1 or 2, I know that my reference triangle has to be in quadrant 2. Cosine is adjacent, which is 8, over hypotenuse, which is 11. You are unfortunately going to have to use Pythagorean theorem to find that third side. So we get 8 squared plus b squared equals 11 squared. 64 plus b squared equals 121. Go ahead and subtract 64 from both sides, and we end up with b squared is equal to 57, square root both sides, and b equals plus or minus root 57. So root 57. Now we're in quadrant 2. We know that sine is positive in quadrant 2. Sine is opposite, which is root 57 over hypotenuse, which is 11. So be careful with the sign. This one's positive because it's sine and it's in quadrant 2. Okay, go ahead and take a moment and do numbers 2 and 4 and then unpause and we will go ahead and go over them together. All right, so number 2, we have tangent of inverse sine of -4/5. So once again, we want to draw this out. Because inverse sine lives in quadrants 1 or 2 and it's negative, we're actually in quadrants 1 or 4. We're actually in quadrant 4 this time. All right, so we have our reference angle theta, and sine is opposite, so which is 4 over hypotenuse, which is 5. Oh, we lucked out. We got another 3, 4, 5 triangle. All right, so tangent in quadrant 4 is negative, and it's going to be opposite, which is 4, over adjacent, which is 3. Okay, let's go ahead and do the last one, and we will be done. So number 4, we have cosecant of inverse cosine of 7 over 25. So we're going to draw our picture once again. Inverse cosine lives in quadrants 1 or 2. Because it's positive, we are in quadrant 1. All right, so we have our reference angle right there. Cosine is adjacent over hypotenuse. So let's use Pythagorean theorem to find that third side. We have 7 squared plus, we'll call this b squared, equals 15 squared. We end up with 49 plus b squared equals 625. Subtract 49. We get b squared is equal to 576. Square root both sides, and b equals plus or minus 24. So we actually get a pretty nice triangle. All right, so cosecant is the reciprocal of sine. Sine is normally opposite over hypotenuse. Lucky for us, we're in quadrant 1, so we know it is positive. So instead, it's going to be hypotenuse over opposite. So 25 over 24 is your final answer. Okay, that is all for today. Thank you so much for watching.